Good evening, everybody. So, in the previous lecture, we discussed about the most economical section and what are the conditions for the most economical section in case of a rectangular channel. If the channel section is rectangular, when a channel section, rectangular channel section will become under what conditions it becomes most economical. Most economical means it carries maximum discharge for a given area of cross section, for a given roughness coefficient, and for a given bed slope. When that is possible, when P is minimum, the wetted perimeter is minimum. That is the condition which we have used and derived the conditions for the most efficient or economical rectangular channel section conditions, which states that the depth of flow is equal to half the bed width, that is y is equal to b by 2, whereas the second condition is the hydraulic radius is equal to half the depth, or r is equal to y by 2. So these are the two conditions that we have derived, and some problems also we have solved in the previous lecture. And this lecture, we devote our time to understand about the same, the conditions for the most efficient or economical channel section if the shape of the channel section is trapezoid. Let us go into straight away the trapezoidal section and try to understand it and derive the conditions for the efficient triangular section. The most economical trapezoidal section. What are the conditions? So this is the question that which we derive. So let us take straight away a trapezoidal section. So this is a trapezoidal section. Water surface. So bottom width is B. Depth of flow is Y. Side slope is 1 in Z. 1 vertical to Z horizontal. So this is the trapezoidal section. So consider a trapezoidal section of bottom width B, right? Depth of flow y and side slopes 1 vertical to z horizontal. That is the first thing. So already I have basically, when I was talking about the geometrical proportions, I have already told you what will be this also. So the central portion is B and the other two portions on both sides are zy. So total will be B plus 2 zy. This is the thing. And then again, what is the side slope distance? Actually, this also you can say this is zy and this is y. So square root of y into square root of z square plus 1. This will be the side distance. So what is A is equal to sum of the parallel sides into the half into sum of the parallel sides into distance between the two. So that will be B plus zy into y, which I already explained to you. And P is equal to, you know, that B plus 2y into square root of z square plus 1 b y plus square root of z square plus 1, this side y square root of z square plus 1. If you add all together, that we get p. So now this is the things. Now say if suppose from the take the first one, actually I can write uh, b plus zy is equal to a by y, or b is equal to a by y minus zy. You should understand why I am writing this also after seeing the rectangular section derivation. We should understand. Now this I will put it actually in the second one. If I put it, then P is equal to, instead of B, I will write A by Y minus ZY plus 2Y into square root of z square plus 1. So this is the thing. So naturally what we are assuming, so assuming what are the constants? A is a constant basically, z is a constant. So here and when these two are constants in the above equation, then conditions for the most economical, for most economical channel section, the conditions should be dp by dy is equal to 0. This is the condition. So if that means that is p should be minimum. If p is minimum, then naturally we should write the same whatever I have used for rectangular channel section, same. So therefore from this you calculate what is dp by dy. So if I calculate here, it is a by y, so naturally that means a into y to the power of minus 1, so minus y to the power of basically if you take it minus 1, so it all becomes actually minus 2. So if you take it minus a by y square, it will be minus z plus 2 into square root of z square plus 1. All this is equal to 0. So if it is 0, so now a by y square, a by y square plus z is equal to, then naturally this will go on the other side because this minus is there, so it will be like this. So already we know what is a, basically a is equal to, you already know that b plus zy into y divided by y square plus z is equal to 2 into square root of z square plus 1. So this y will cancel, right? When both will cancel, basically this will cancel. So remaining is b b plus zy by y plus z is equal to 2 into square root of z square plus 1. A little bit of b plus zy plus zy by y is equal to 2 into square root of z square plus 1. So b plus 2zy is equal to 2y, or b plus 2zy by 2 is equal to y into square root of z square plus 1. Now if you take it, what is b plus 2zy by 2? This is the half of top width is equal to side slope distance. So this is first thing. So this is the first condition. Half of the top width is equal to, basically we are getting the condition side slope distance. So this is over. Then second, let us take the second. Already you know the second is equal to, or is equal to a by p. What is a by p? B plus zy into y divided by b plus 2y into z square plus 1. So if I write it like that, what is b? You see the top one. From this, if you see how I will write b, you see b is equal to, basically it is 2y into z square plus 1 minus 2zy. Can I write like that? Plus check it up, right? B plus zy into y divided by b is equal to, again here also what we can write, 2y basically square root of z square plus 1 minus 2zy plus 2y square root of z square plus 1. If I write like that, basically if you see it, then naturally so the top one you see it minus 2zy and this is plus zy, so it will be finally minus zy basically into y. So what I can write, 2y into square root of z square plus 1 minus 2zy plus zy. So minus zy into y divided by 2 into, right? If I take 2 into, what is the thing actually? Here it is 2y, basically square root of z square plus 1 minus zy. Because this is one total. So if I cancel this and this are same. If I cancel, it will be. So what is the second? R is equal to pi by 2. So these are the true conditions. So what are the two conditions for trapezoidal section? Condition 1 is equal to half of top width is equal to half of top width is equal to half of top width is equal to side slope distance. And second one is what? Basically hydraulic radius is equal to half the depth of flow. So this means the first one is what? It is b plus 2zy, that is top width, by 2 is equal to y into square root of z square. What is the second thing? R is equal to y. So this completes the thing actually. So there is one more condition also in the case of trapezoidal section. The third condition may also require in some conditions, in some specific problems. What is that is what is the best side slope for trapezoidal section? The best side slope for trapezoidal channel section. So the what that means what they're asking is suppose this is the channel section. This is B, this is Y, right? This is one. The question is what is Z? This is the question, right? So now this is the one of the again. So when you are finding out this, basically again you can start and do the derivation. A is equal to, we know that it is again A is equal to B plus zy into y, or B is equal to A by y minus zy. P is equal to, we already know B plus 2y into square root of z square plus 1, like regular. So I substitute in that. So if I substitute in that, this is A by y minus zy plus 2y into square root of z square plus 1. Now in such a case, when you want to find out the what is the what is the best side slope, best side slope, right? Then here actually A and Y are constants. Z is variable. So you need to do basically the difference for P to be minimum. dP by dz is equal to 0. That is the condition we use. So d by dz of a by y minus zy plus 2y square root of z square plus 1 is equal to 0. So if I put it, then if I do it, what is this actually? So in the first one, naturally, this becomes 0 because a is constant, y is constant. The second one, if I take it minus y, then if I take it plus 2y into 1 by 2 into square root of z square plus 1 into basically for z square 2z, this is equal to 0. So if this is the case, now you see minus y, so 2y, 2 will cancel, so what will be there in the top actually? Plus zy divided by, basically what will happen, this will 2zy by square root of z square plus 1 is equal to 0. So if I take it minus y into square root of z square plus 1 plus 2zy is equal to 0, right? Or basically if I take it now minus y, if I take it constant here, right? Minus y or y, if you take it, this is actually if I take minus y, if I take it better, so what will happen? So here it is z square plus 1. Here it is what will happen minus 2z, right? Um, is equal to 0. So as y cannot be 0, it's a constant. So naturally, square root of z square plus 1 minus 2z is equal to 0 as y cannot be 0. So therefore, basically, if you see it square on both sides, z square plus 1 is equal to 4z square. Or if I take it 3z square is equal to basically 1. Or z square is equal to 1 by 3. Or z is equal to 1 by root 3. This is what we want. Z is equal to 1 by root 3. This is the best side slope. Right, how it will be if I take it the channels, for example, this is how I am taking, it is 1 and z will be 1 by root 3, this is that. So if I take this as theta, tan theta is equal to 1 by 1 by root 3, right? If I take it, it is root 3, it is equal to tan 60 degrees, so theta is equal to 60 degrees. So this is as far as the trapezoidal section is considered.
Like, share, and subscribe. Hit the bell icon for more updates.